Okay, so it's 9:31 and we'll get started. I have informed someone that we're having trouble with the internet, so hopefully they'll fix it. There are a couple of things very early on that we'll do that will require those packages. So if you do not have those packages installed already, I suggest sort of finding a neighbor that does. So you may need to stand up and rearrange, but I think you should do that now because it'll be better for you. So if you don't have the tidyverse or recursive, ask a neighbor and see if they do, and you can make a new friend. Okay. Okay, so I will get started just so we stay on time. Welcome to the Solving Iteration Problems with purrr tutorial. There's only two things you need. One is the slides, and then the other are these two packages. Packages are more important right now. There will be time to sort of get the slides in the break for the few things that you need to copy and paste. Okay, so what do I mean? Like, why are we here? What does it mean to solve an iteration problem? The way I think about an iteration problem is it sort of takes this form. For each blank, do blank. That is an iteration problem. When you want to do something to every element of something else, that's an iteration problem. And I think you are probably already solving these problems. They come up very early on when you want to do things with data. And there's multiple ways that you might be solving them. The sort of simplest way, and it's certainly the way I started when I learned to program R, was simply copy and paste. When I needed to do something again, I would copy the code, I would paste it, I would make a tiny change, and run it again. For loops, of course, are the classic way of solving iteration problems. And then the L and sapply functions in R also solve iteration problems. So I know you're already solving them. Really what I'm going to do is show you an alternative, that the map function in purrr, and we'll see a few variations on that function, its friends, as we go along. All of these materials, the slides plus some code for all the exercises, is available on GitHub. I wouldn't go off and grab that right now just because you might see some of the answers, so save that for afterwards. And there's just the link to the slides again. Okay, so we're going to sort of jump right in. I want you to get warmed up a little bit, so I have an exercise for you. So whenever you see this blue heading, your turn, that's when I'm turning it over to you, for you to do something. So all I want you to do is load that recursive library. And then I have a couple of questions for you. I want to know how many elements are in the SW_people object, who's the first person in that object, and what information do we get about them. And then what's the difference between looking at the first element with a single square bracket and the first element with a double square bracket. So I'm going to give you about 4 minutes. I think that's a little long for this, but it'll give you time to get the slides or the packages as you need. And if you think you've answered these questions, have a chat to your neighbor and see if they get the same answers. So I'll give you 4 minutes, and if you have any questions right now, just flag me down and I'll come talk to you. Okay, that's your 4 minutes up. So let's take a look. I'm going to switch over to RStudio. I'll make that a little bit bigger. Okay. So I got you to load this library, Recursive. That's a package written by Jenny Bryan, and it's just a collection of data sets that can be kind of useful for practicing some of these iteration skills. And I asked you to look at that SW_people object. Did everyone figure out what kind of object that is? Well, that wasn't a specific question, but you probably figured it out along the way. A list, yeah. So lots of ways you could have found that out. One would have been with str people. And if you did that, you would have got reams and reams and reams of output. I don't know if you know about the max level argument, but it can be quite useful to sort of limit how deeply that str prints. So if I say just give me max level 1, it's just going to print the structure at the first level. So this SW people is a list of 87 elements. Pretty sure I didn't touch anything there, but we'll see if it comes back. And that was one of the specific questions I asked. You could have sort of looked at the structure to figure that out. I'm hoping you also maybe thought about the length, the length function, which would have also told you 87. So if I make stupid mistakes, you can take a look at my natural time zone, and I apologize, but my brain thinks it's 4 in the morning, and it'll probably struggle a little bit. Okay, so that was one question. The next thing I asked was who the first person was. Did anyone figure that out? Luke Skywalker, exactly. So you could have gone, it sort of just had a look through all that output to try and find him. Or perhaps you remembered your square brackets because I had them there. And could have had a look. So what kind of information do we have about him? So we have his name, it's Luke Skywalker. There's things like his height, his mass, his hair color, skin color. There are a couple of unusual elements here, things like this homeworld element, films, and species, where the information we're getting is actually a URL. If you went to those URLs, you might, if you're curious, you'll actually get information about. So, for example, if you went to this homeworld URL, you'd actually find that that was Tatooine, and it would give you some information about that homeworld. How am I doing on my questions? Okay, so what's the difference between asking for that element with double square brackets and single square brackets? Does anyone want to volunteer a suggestion? Yeah, in the front?
Double square bracket will return atomic vector, and single square bracket will return a list single atomic vector.
Yeah, so you said the double square bracket will return an atomic vector, and the single square will be a list with the atomic vector in it. It's not quite right, because it can return another list, well, which is, yeah, this is what's happening here. So the double square brackets gives you back the contents of that first element, and in this case, that's a list. The single square brackets gives you back another list, just like the original list. It just only has one element. It's not super important for us, but you will see a couple of times I'll use the double square brackets when we start talking about how this iteration is working. And just remember that that's giving us the contents of that element. Okay, so you may have figured out that object had something to do with Star Wars. So the SW_people object is actually a list of all the characters in the Star Wars movies. So we're going to kind of use this data to practice and to learn about map and to practice our purrr skills. So we're going to kind of tame that Star Wars data with purrr. And that data is coming from a website called the Star Wars API. And it's an API you can query, and it spits back JSON or XML. And sort of most naturally in R, that gets converted to a list. And it's a list that's sort of hierarchical in nature. And we're going to kind of use that hierarchical list to practice our purrr skills. And sort of full credit, that data inside Recursive, I used Oliver Key's, I think it's, now I'm going to get it right, it's called RWars, the package is called RWars, which will actually query that API right from R for you. Okay, So first thing we're going to do is talk about this map function. And the map function in purrr takes two arguments, this .x and a .f. And what it really says is for each element of that first argument, .x, do .f. So .f is going to describe what we do. And .x is always a vector. And you'll find that with a lot of the purrr functions, if an argument is called .x, it is expecting a vector. But in R, a list is a sort of a special type of vector. So you can pass in a list as .x, and it will be doing something for every element of that list. And similarly, a data frame in R is a special kind of list, so you could also pass in a data frame. It gets a little bit tricky there because when a data frame is thought of as a list, it's each column that's an element. So if you pass in a data frame, you're going to be doing something to each column. Okay, so that's the sort of first thing. That first argument is a vector. The .f we're going to get to. So there's a lot of ways of specifying it. We're going to start with what I think is sort of the easiest way, and then we'll talk about the other ways of specifying .f. Okay, so here's a question that we might ask about this specific object, SW_people, and it's how many starships has each character been in? So that is an iteration problem. Because what I want to do is for each person or each element in that SW_people list, I want to count the number of starships. So for each blank, do something. For each person, count the number of starships. That immediately tells us what our first argument to map should be. It's that object that we want to iterate over for each person in this SW_people object. So that's our first argument sorted. So all we have to do to sort of answer this question is figure out what that .f argument is going to be. And I'm going to sort of suggest this strategy for doing it. And that is, first you figure out how to answer this question for one element. Then you turn it into a recipe, and this is kind of a shortcut that purrr provides that's a little bit different to anything you might have seen in sapply or lapply, but I'll talk about how you do that. And then you just kind of, once you've done steps 1 and 2, actually doing this for all the elements is just a matter of plugging in the right things to map, and we'll see that. Okay, so the first part of that strategy is to do it for one element, solve the problem for one element. So again, I'm going to turn this over to you. We're going to create this object called Luke. It's just extracting the contents of that first element in Star Wars people. And I want you to write a line of code that simply finds out how many starships Luke has been in. And I'm going to give you about 2 minutes to do this. It's not a trick question. It shouldn't be too hard. And if you get bored, there's a more complicated question there for you to try and answer. Okay, your 2 minutes is up. Is there anyone that feels like they'll need a little bit more time? If you could raise your hand. No, great. So 2 minutes was perfect. Is anyone willing to share? Hang on, let me find my mouse. Let me just get Luke defined. So I'm. No, I'll just do this. So someone just yelled out the answer. 2. So how did you find 2? Length of? Yeah, so you had to do a little bit of detective work just to figure out there was a Starship's element there, and that it contained essentially these URLs to a couple of unique starships that Luke has been on in the movies, and to count them, we just have to look at the length. Okay, so we've solved it for one element. The easiest way would be to look at the names of the starships. That is a great question. It's slightly complicated. So this was the more complicated question, right? I won't tell you exactly, except that you have to look at SW starships and essentially match the URL in the starship element of Luke to the URL in the URL element of a starship. And we'll see an example of doing something like that soon. Okay, so this is the sort of first part of our strategy. You do it for one element, and we've done it. If Luke is our first element, we find how many starships he's been in by looking at the length of his starship's element. So Luke here was kind of our key. That was just one element in our SW people list. We could have equally used this exact same code to do it for a different element. So maybe we'd define Leia. She happens to be the 5th person in this list. We could similarly find how many starships she's been in. And it doesn't really matter what element we're talking about. This length, or you take this element, you find the starships element of that element, and then you find its length. That's always going to find how many starships that person has been on. So purrr provides this sort of shortcut for specifying what we want to do. And here we kind of have an idea of what we want to do. We just have to translate this into the way purrr expects it to be there. So I kind of call this turning it into a recipe. That's sort of my own turn of phrase. In all the purrr documentation, it just talks about a shortcut, a formula shortcut. So the way we do that in purrr is we specify this function as a formula. And in R, the way you tell R something is a formula is you simply put a tilde right in front. So that's sort of the first step. We're going to turn this piece of code we have into a formula by sticking a tilde in front. And then the other thing purrr provides is sort of a pronoun for describing the element we're talking about. Or you can kind of think of it as a placeholder. So we simply put a .x wherever we're talking about a single element in our example we've worked. So where instead of sort of having Luke here or Leia here or a specific element, we're going to say .x. And you can think about it as a pronoun and just sort of think about it as an it. So we take it being one element, we find the starship's element, then we find its length. Okay, so this is our little recipe. It's tilde length of .x $starships. And that is going to be our .f argument to map. And I'm sorry I lost my x there. I'm hoping it's going to come back. There we go. My comma's in a slightly unusual place. Okay, so we already figured out that our first argument should be SW_people. That's what we want to iterate over. So we're going to map SW people. The second argument, .f, is exactly this recipe we just generated. So this is the sort of purrr shortcut way of specifying what we want to do. Because that previous slide had a lot of transitions, if you want to try out that code, this is the slide to copy and paste. Okay, so now I want you to take a go at this. I'm going to get you to create this planet_lookup vector. And it's just these sort of 2 lines of code that you'll need to run, so you'll probably want to copy and paste that from the slides. And for now, I want you to ignore the details of how we create that, and I promise that we'll come back to those 2 lines of code and you will understand exactly what is happening. For now, just create it, and take a look at planet_lookup to see essentially what that vector is the correspondence between those planet URLs and the planet names. And then I want you to solve this problem, this iteration problem. I want you to find the name of each character's homeworld. I want you to use the strategy. So do it for Luke, turn that into a recipe, and then do it for all. So you're putting a few things together there, so I'm going to give you 4 minutes, and make use of your neighbor if you get stuck. Roughly 18. Doing it first and then we'll come back, yeah? Yep, no problem. Okay, your 4 minutes is up. How do people feel? Does anyone need more time? maybe just a couple. I'll walk you through it. This one is just a little bit trickier because there is a little bit of an R idiom at play. That if you've seen it before, it's really easy, but if you haven't seen it before, it can be a little bit tricky to understand. So that planets lookup vector is a named vector, where the names are those URLs. Those are the URLs we might expect to find in the homeworld element of our people. And the actual value in the vector is the homeworld name. So if we look at Luke homeworld, we get back that URL. So we need to be able to use this planet lookup vector just to say, okay, here's the URL I have for us homeworld, tell me what the name is. And this is kind of where that R idiom comes in. You can subset vectors by name. So I can actually look up, I'm going to use my planet lookup vector. I'm going to look up the element in that planet lookup vector that has the name that matches the value of Luke's homeworld. So that was maybe the tricky bit that you may not have seen that kind of lookup before in R. It's a pretty common thing you'll see done. So that's solving it for one. We see that Luke's homeworld is Tatooine. So the second part of the strategy is to take that sort of specific solution for one person and turn it into one of these recipes. I'm going to grab a piece of code and do this up in the editor just to make it easier. So the first thing you do, you turn it into a formula. You just put a tilde in front. The second thing you do is instead of having a specific element, you use this .x pronoun. So I don't want to do it actually for Luke. I just want to do it for any element. And then you just sort of wrap it all up in the map syntax. So I want to map over SW people. That's my, let me be specific, that is my .x argument. And that recipe I've written is going to be my .f argument. Just like that. And then I'm just going to run that just to prove that it indeed worked. And we'll talk a little bit about making this output a little bit better, but right now what it's returning is a list of 87 elements, and each element is going to be the homeworld of that corresponding person. So for the last person, it happened to be Naboo. Okay, any questions so far? We'll get to that. So the question was, how do you print the person's name, right? Part of the problem with this output is it's a little bit messy because it's still got these names of the URLs hanging around. It's also a list, which maybe I could have used a vector here, and I've also lost this correspondence between the person and the home world. We will solve all those problems, never fear. Okay, so we've done that. Okay, so the good news is that we're half an hour in, and you have just used purr. Like, that's all there is to it. So hopefully you're purring. That's my cat Scylla sleeping on my laptop to stay warm. So I feel like I missed a slide because I was a little tired. Yeah, I didn't miss a slide, I just misspoke a little bit. One thing I should kind of point out now is, so this is the link here to the purrr GitHub page. So purrr is considered part of the tidyverse. And one thing I should say is I did not write purrr. This is a Hadley Wickham package, not a Charlotte Wickham package. But I can take full credit for the hex sticker. I did design the hex sticker, and I have like 2 packs of them, so you have to talk to me at the end. You'll have earned a sticker. But there's sort of a few, it's considered part of the tidyverse, so it works really nicely with some of the other tidyverse packages, and we'll talk a little bit about that later. Okay, let me go back to where we were at. Okay, so this is sort of essentially what we're going to do for the rest of today. We've talked about the map function. The next thing we're going to talk about is the sort of family of functions. They start with map, there's an underscore and a suffix, and they return different kinds of output. So they're going to work just like map. The only thing that's different is the kind of output you get back. We're then going to talk about different ways you can specify .f. So what I showed you was a shortcut to specify .f, but there are sort of the non-shortcut ways to do it, and then there are a couple of shorter shortcuts that we'll talk about. And then we need to talk about some of the other iteration functions. So up to that point, we'll have only talked about map, but there's map2 that will handle kind of iterating over two objects. There's a pmap, invoke map. We'll also talk about those. And I think that'll probably take us a little bit past the break. And once we've talked about all that, I'll talk a little bit about using purrr with tibbles and list columns. Yes? Sure, I think I have a slide about that. But since you've asked the question, let's just jump to it. It's not that far away. Yeah. So the question was like, why this feels a lot like sapply and lapply. Like, why use purrr? And that's a great question. I mean, the essential answer is that if you use lapply, there isn't a huge, you're going to get the exact same results as if you use map most of the time. If you're a fan of sapply, things can be a little bit more complicated. And the problem with sapply is that just knowing that you used sapply isn't enough to know what kind of object is going to come out. So sapply has some unusual sort of, well, I mean, can be very useful simplifying features, but they can also make it harder to predict what's going to come out. So one thing we'll talk about with purrr and the map functions is you always know what kind of output you're going to get. There won't be any surprises, which makes it a little more robust when you're sort of programming with it. So that the answer is, I won't go into exactly those cases, but you're welcome to talk to me about it. So the motivation for purrr is first that there is that consistent return type, that you're always going to know the kind of object you get. The second is that you get these useful shortcuts. So that sort of recipe we just saw, that way of specifying .f, saves a little bit of typing. So that's another reason to use purrr. The other thing is that you get these other functions for more complicated iteration. So lapply doesn't really have this sort of I'm not entirely sure I'm making a correct statement, but if you want to iterate over two objects, there's sort of not a natural way just to extend what you had with lapply. Whereas with map, we're going to see map2 that just naturally extends map, and everything else is sort of consistent and works nicely. The essential answer is it's just a little more user-friendly. It's not really going to do anything new and amazing that you can't do already. It's just more user-friendly. Okay, so let's get back to map. And this kind of nicely links to what we're just talking about, that map is always going to return a list. So we saw when we just used it that what we got back was a list that was just the same length as the SW people that we put in as .x, and that will always be true, or you'll get an error. Often you don't want a list back, right? The whole point of kind of iterating over this list is you might be trying to kind of extract some simple information and you just want a simpler type of output. And the way that that's handled in purrr is that you use a different function. So there is a function that's called map_LGL, and that will, instead of returning a list, return a logical vector. That vector will be the same length as the original list that went in, but it's now going to be a logical vector. There's map_int for an integer vector, map_dbl for double, and so on. You can kind of you can see the pattern. There's one other function with a different name called walk that works just like map, except you use that when you don't want to return something. So that's more useful when you want to use a function. You want to do something to each element, but the thing that you do, you don't really care about what's being returned. You just want its side effects. So that's things like printing a plot to the screen or saving a file to disk, that kind of thing. So we'll see some examples of that later. So the result sort of being that you get no surprises. If you see in your code that you used map_LGL, you know that what you get back is a logical vector, or you're going to get an error. There's sort of no automatic simplification going on. And that vector will always be the same length as the input. Okay, so I'm going to get you now to practice that a little bit. I have this first line I want you to run. All it's doing is taking our object, our list of people, and giving those elements names. So the set underscore names function, I'll talk a little bit more about later, so don't worry about too much now, but essentially we're just giving the elements of that vector names, and the names are the character name. So this is just going to make our output a little bit easier to understand. And then I have 4 things I want you to take a look at. These are 4 map statements, so in each case they're going to return a list. I want you to swap out that map with a map underscore something to get simpler output. I'm going to give you 3 minutes. Don't get discouraged if on the last one things are a little bit harder. I'll talk about that one. It is intentionally a little bit harder. Does that mean Revolution bought their monkeys again? Oh yeah, Microsoft, sorry. Is there a monkey over here? Okay, your 3 minutes is up. So there's sort of 2 strategies here you can use. You can take a look at what we're doing and try and guess the right function, or you can run the map statement and then take a look at the output and see if you can guess the right function. So we've already done this one where we counted up how many starships each character was in. So anyone want to take a shot at what the right function might be here? I'm hearing some whisperings of int. So map underscore int, that works here. We basically, because we used length, we're kind of almost guaranteed to get an integer. And you can see what we get back now is an integer vector, and it's exactly the same length as the input. It's 87. Sorry, the one thing I forgot to do just then was run this names setting the names. So the reason that I set the names there is because these map functions will sort of preserve those names, which makes it a lot easier for us to actually see kind of what data we got back. So if we set those names, then when we ask for this integer vector, it's a named integer vector, and the names of that vector are just the same as the original name. So it's a little bit easier, a little bit more user-friendly here to see that Luke Skywalker has been on 2 starships, and that second character happened to be C-3PO. Okay, what about that next one? What color is each character's here? What map function? Character. Yep, that one's worked. What about if they are male? LGL for a logical. And then what about how heavy is each character? DBL. Good, because that's what I would have guessed too. What happens? You get an error. So this is kind of an example where we've asked for a simpler object. We've asked for a double vector. And purrr is saying, hey, I can't convert this to a double vector. You're doing something wrong. So there's sort of 2 ways to deal with this kind of problem. And the first thing I'd recommend is just stepping back to map and actually having a look at what you get back. And you'll see that, yes, for some people, what we get is something that looks like a number. For other people, we get this string unknown. And you'll actually see that even the things that look like numbers are actually being reported as strings. So what's being returned here are character strings. So we could sort of solve this if we wanted that simpler object, just ask for character strings. We're going to get them. If we really want the masses, we're going to have to do a little bit more work with this particular character string. And I know I've done that. I haven't. I don't think I can recall it from memory right now, so let me just cheat. Yeah, so one thing you could do, you could either kind of, in your shortcut, in your recipe, you could kind of try and force that conversion yourself. So instead of just asking for the mass element, I could ask for it and then try and convert it to something numeric. It's a little bit risky to do that, partly because what those strings that were unknown are now just coming back as missing values. There's a function called pass_number in readr that does that a little bit in a less risky way. In particular, you can specify what a missing value is. So you could, if you want, try to force those back to be numbers. There's some particularly... can you see it? Yeah. That's a great question. So the question is, how is this different to as numeric? And I've just found the example of how it is different. Let me just get back this one. So it's a little bit annoying that I've lost the names. But one, I know, has anyone got a guess who this character might be that was 1358? Jabba the Hutt. That is a great guess. And it is indeed Jabba the Hutt. And what you'll find if you do the as numeric, and now I'm going to have to search for Jabba. There he is. He actually has quite a complicated name. The as numeric came back as an NA. And that's because that particular element, do I know? Can I do this on the fly? I can do it. Okay, SW people. So because I set those names, I can now query by name. And if you have a look at his mass, right, the problem is it's got a comma in it. So if I just do as.numeric, it says, hey, this has got some things that aren't numbers. It's obviously a character string. You don't know what you're doing. I'm going to give you a missing value. Whereas that pass_number is a little bit more sensitive to the way numbers might be formatted and can handle things like commas. Okay. Okay, so that's sort of how you get different and simpler return types. The other thing I told you we'd talk about is other ways of specifying this .f. So the way we've seen it is a shortcut that purrr provides, and that's using a formula. So we started it with a tilde, and then we had some code that did something with a placeholder .x, and that's how we specified it. But that is a shortcut, and we've seen some examples of that. I'm going to come back to these examples as sort of, we're going to use some shorter shortcuts. So we've seen sort of counting the starships, we've seen pulling out the hair color and pulling out the mass. The shorter shortcuts, there are two, and that is that .f can be a string or it can be an integer. So instead of passing in sort of a formula that describes what to do, you just pass in a string or you just pass in an integer. And what that does is pulls out that element from each element. So if I specify .f as sort of some name, so a string that contains the text, some underscore name, that is going to, or is equivalent to us specifying our shortcut or our formula that takes the .x element and pulls out that some name element from it. Because this is sort of such a common operation that you want to look at each element and pull out a specific value, that's why it kind of gets this shorter shortcut. And it means that some of the examples we have already had, we can write in an even shorter way. So if all we're doing is pulling out the hair color from each element, we can simplify that. Instead of specifying that formula, we can just specify the string here underscore color. And that's the same with integers. So you could just give a number here, and that's just going to pull out that number element. So if I put a 1 in there, if I say map underscore char SW people 1, I'm just going to get the first element back from every person. The other thing .f can be is simply a function. Right? We've been using this shortcut to essentially write our own functions. But if there's a function that exists that already does exactly what you want to do, you just pass that function in as .f. And that's kind of equivalent, in this case the shortcut is not a shortcut, but that's equivalent to specifying a function, specifying a formula where we're calling some function on each .x and we're passing in some additional arguments possibly in the ... So map does have that ... You can always pass in other arguments, and those arguments are being passed on to that function that you're using. So just as an example of that, we could sort of create this new object, char underscore starships, that's just the starship element from each person. That's using the string shortcut. And then we could take that list and just apply the length function to each element. So that's exactly what we've already done. It's just counting the number of starships everyone's been on. It's just doing it in a slightly different way. And you can then kind of start using some of the other tools in the tidyverse to kind of make this a little bit more readable. So here we're using the pipe. So essentially we're doing this in one go. We're saying first, for each person in SW people, pull out the starships element, then take that and iterate over it again with map int, this time calculating the length of each element. And that's kind of also equivalent to the way we originally did it, where we wrote sort of a shortcut formula that took each element, pulled out starships, and then found the length. I actually have a slight preference for that middle option. I think it's a little bit easier to sort of do simple steps one at a time and see how they go before trying to put it all together. So don't be afraid to sort of break things down. First I want to pull out all the starships, then I'll figure out how to count them. Okay, so I kind of showed you this earlier. I got you to create the planet underscore lookup object, and I told you to ignore the details, and now I want to talk about them. So what's happening here? So the first thing to kind of notice is I'm doing two things here. I'm doing two things in succession. The first thing I'm doing is I'm using map underscore char to pull out the name element from every planet in the planet's object. So that's going to give me, I know because I'm using map underscore char, it's going to give me a new vector. It's going to be a character vector. It's going to be the same length as that original planet's object, and all it's going to contain is the name of the planet. And then I'm passing that on to the setNames function. And the names I'm setting, I'm using map char again, but this time I'm pulling out the URL. So I'm setting the names of that character vector with the planet names to the URLs that match those planets. If you have people, who has not seen set underscore names before? If I could see a show of hands. Okay, cool. This is good then. Okay. I was going to tell you exactly what it does. You have probably seen this kind of syntax on the right. Right, if you want to change the names of an object, you have the names function on the left-hand side of the assignment, and then you give on the right-hand side the names you want to use. So give X the names in Y, and then I can take a look at X, and it should be named. That is equivalent to sort of this, well, the set names function takes two arguments, an X and a Y, and it basically takes that first argument X and gives it the names in Y. But once you sort of combine that with a pipe, it says, take the object X, pass it on to set names, and give it the names Y. The advantage of the syntax here is that it actually, like if you run that, it's returning the named vector. And that makes it a lot easier to use sort of in a pipeline. Whereas if you're using the names function and you actually want to return that named vector, you've got to explicitly say, hey, give me X now. So it's just, all it is a function provided by purrr that makes, I think it's in purrr, that makes it easy to add names to things when you're using the pipe operator. Okay, so now you know how to do that. And we talked about this before, so I'll just remind you. This all looks very much like sapply and lapply. The big motivation for purrr is that you get this consistent return type because you, just by looking at which function's being called, you know what kind of object you're going to get back. There are these useful shortcuts, so we've really focused on that formula shortcut. The way to think about that is that it's a shortcut for writing an anonymous function. And if that doesn't mean anything to you, don't worry about it. But that's what's happening in the background. And then it's got this consistent syntax. So once you've mastered map, it's going to be pretty easy to master map2 and pmap and these other purrr functions. Okay, so that, I can delete this. We've been going for about an hour, but our break isn't scheduled for another half an hour. So I kind of had these challenges here, which you should now be able to answer with everything you know about purrr. And it's using that same Star Wars data. So which film has the most characters, which species has the most possible eye colors, and which planets do we know the least about. So I want you to try and tackle these. Let me think. So what I'll do is I'm gonna give you 10 minutes. Try and tackle one. If you would prefer to use that 10 minutes to get up and stretch and get some water and go to the bathroom, that's fine, but I will start promptly when your 10 minutes is up. And I'll probably just review one of those, but feel free to try them all if you want to. Okay, so 10 minutes starting now. Let me just make sure I'm, you're like, Zach.
Here we go. You can.
Yeah, so I could have.
You could SWP map. Pipe map.
Yeah.
Like I'm trying to think if there is any reason not to. On the surface, it seems you want to. But
I mean, I don't think there. I think it's just.
so
I think.
so you,
I think it's like a personal. Like I tend to not start piping until I have. Yeah, I don't know. Like I feel like when I code, I'll start with this, right? And then if I want to do something else, then I'll be like, oh, okay, well I can pipe this in. And I don't tend to go back and rewrite that. But I see where you're coming from, because it would make more sense to say, like to have that right at the start, say, this is what I'm
Because
starting with.
Right, deep layering, you always want to start with listening
Yeah.
data. I
Yeah.
do this, I do this, I do
Yeah,
this, I do this.
yeah, exactly. So here's my list. I do this, yeah.
Just think
Yeah, it is. Can you, oh, sorry.
about it. Sorry.
Can you, well, don't worry, I'll do it. I just
Email
want to, yeah, just contact me somehow. I don't care
Tell
how
me
it
to
is,
do-
and
sure,
remind
sure.
me
Which slide
that
was
we
it?
talked about it. Let me just get this up for these guys. I don't know.
I'll write here.
Just say, if you just say something about piping, I will remember.
I have my ever long prolonging to-do list.
Cool.
You know to do TXT?
I do, you know.
And how, what do you say to do?
Well, normally just to do all types of features.
Precisely. So this is the concept of saying, okay, we're using to do TXT file anyway. So keep it in Dropbox. This app will sync it to run in Dropbox to your smartphone. So then this is to
Okay, that was 10 minutes up. So just out of curiosity, can I see a show of hands for who completed the first task? Cool. How about the second task? And how about the third task? Just a couple. Okay, that's kind of what I expect. Like, I hope that you can get through one of these tasks, and I know that there will some people will have enough time to get through all three, but they do get progressively harder. So that's to make sure no one runs out of things to do. Let me just go through one of them, just to kind of illustrate like how I might kind of think through the problem. And I believe you can find sort of my rough solutions for all of them on the next slides, and possibly also in the GitHub if they're not there. So let me take a look at that first one. So I want to know which film has the most characters. So the first thing you have to know is that you have to go look for this SW Films object. And, you know, I generally do start with that strategy. This isn't something I made up just for you. I pull out one element, and I take a look at it, and I try to solve the problem. So if you look at one film, you'll find, as you scroll through it, there is this element called characters. That's the one that lists sort of these URLs that link to all the other characters. This is so similar to our other example. It's almost not funny, but I could look at the characters, and then I could just count them with length. Right, that's how I solve it for one. I know then I can use the shortcut. Well, I might have done, this is actually a pretty easy one, right? I could have gone this kind of complicated route of turning it into a recipe, etc. The other thing I could remember is that I can use that shortcut just to pull out the character from each element, just by providing the strings characters. And then I might, that doesn't get me the length though, so I might have to pipe that on and get, there's lots of ways I could have done this, but let me just take that list and get the length out of each element. Right, that's still going to be a list, and maybe I don't want a list, so I'm going to change that last map to an int, so I get back those counts. I'm still not super happy because I don't have which films those correspond to, so I might kind of add on a set names, and what I want is the names of these of each element to be the title of each film. So again, I can use map to do this. For each film in SW Films, I need to extract the title element. I knew there was a title element. You might have had to go look at it. And I had a bracket in a funny place there. That's what went wrong. So that's a little bit better. You know, I might be asking this question because I want to know which film had the most characters in it. I think is that what I said? Yep. So one thing I could just do is just pass that on to sort. Pipe that in. Now it's sorted in ascending order, and I get Attack of the Clones as the most characters. There is a question. Yeah, so the question is, I've used map twice here, rather than when I could have potentially written one map statement and done the pull out the characters and find the length in one go. Is there a performance problem there? And intuitively, my answer is probably yes. And also, I probably don't care. In this case. And I think that's generally true, like you don't really care about performance until it's a problem, and then you care. The map functions, you don't use purrr because you are someone that only cares about performance. You use it because it makes it easy to specify these kind of, solving these kind of problems. But the simple answer is probably yes. Right, because there's a little bit of overhead that map has to kind of set up this iteration. Any other questions? Okay, so I've gone through that one. I'll kind of leave the other ones as homework, and you can go over to the GitHub to figure out answers. Some of my answers aren't very good, and I say that, so feel free to improve them. Okay, so we basically have learned now about map. And we know that map has these kind of friends that go with it that give us simpler output. So you know what to pass in for .x, and you know a few ways to specify that .f. Now what I want to talk about is some of the other functions that purrr provides that do iteration. So we saw map, and you kind of think about map as for each element of .x, apply .f. So I kind of have my emoji version of these functions to help you remember. So here's my .x, which is a list of cats. So for each cat, you could give it a fish, and the result being a new object, a new list, where each cat now has a fish. So the function that I sort of mentioned walk. Walk is just like map. You want to think about it as a typed object. I'll grab your question in a second. But you don't get, or you're not interested in the return type. And this is kind of a hypothetical. These aren't real functions. But you sort of expect nothing in return. In fact, you do get .x back. So if you run walk, there is a result that comes back. It comes back invisibly, and it's just .x. So you get the original thing back unchanged. And the only reason that happens is because it makes it easy to use sort of in a pipeline that you can. So something that walk is useful for is like saving things to disk. You don't actually want necessarily the result of the write underscore CSV function, but you do want it to write something to disk. So you can kind of embed that right in the middle of the pipeline. You want to write these elements out to disk in some form, but then you want to keep going. You want to take those elements and keep manipulating them. I like to think of with my cat analogy, I like to think about this as loving a cat. Like, no matter what, like cats can just be real, I don't know, I won't say any inappropriate words because I'm being videoed, but you really cannot expect anything back. Like, you get a good cat, they're going to love you back, but you get another cat and they really don't care, so expect nothing in return. So I sort of talked about you might use this for saving out files. It's useful for like printing graphics to the screen, or printing output to the screen. So maybe in the middle of a pipeline, you really just want to know some summary statistics for each element. You could spit that out with walk. File manipulation. This is probably one of the places I use purrr a lot is, you have a whole chunk of files and you need to do things to them, maybe saving them, writing them, moving them, that kind of thing. Same thing with system calls. So you might need to, from R, call something else that's running on the command line. Okay, so the new one to us now is this map2 function. So to think about map2, you basically take each element. Before I do that, I forgot I was coming back to a question. So there was one question there. Yep. Yeah, but with a list. Can we talk about it later? I need to think about it, and I think there are easy ways to do it. So we'll talk later. And there was another question in the back. Yeah, so the way the way I think about it is kind of like you're walking a list. Like you have all these elements, you want to visit each element and do something, but you don't really care about the result of that operation. Map, I don't have a good, map, so I kind of know map came, map is a concept that is true in most functional programming languages, like it's just kind of, it was a long time before purrr came along, there was map. It just exists as a concept. And the way I kind of intuitively think about it is it's really kind of creating a map between the elements in our input and the elements in the thing we want at the end. I don't know if that helps you think about map and walk, but That's my kind of, yeah, thanks. Okay, so map 2. Essentially, map 2 is going to take what we were doing with map, and now we're going to iterate over 2 objects. So it has an extra argument .y, and you think about to each element of .x and corresponding element of .y, do something, do .f. And you always get a list back unless you use walk2, which gives you nothing, or map2 underscore LGL, etc. So map2 has all these friends that give you that specific kind of output you want. Map2 will always give you a list. So we're thinking about our cat vector. I'm now going to provide a .y, and that .y has to be an object that's the same length as .x, because we're going to kind of think about doing something to the first element of both, and then the second element of both, and then the third element of both. So I'm going to provide just this vector of numbers. And you could think about using like the rep function in R just to repeat those objects. So for each cat and corresponding times, that's kind of my second element here, I'm going to apply the function rep. So the first element here gets repeated 3 times. The second element gets repeated 2 times, and the third element 1 time. So it's quite important to kind of keep in mind that there is that correspondence, that we're doing something to the first elements of our x.x and .y, and then the second elements, and so on. Okay, so I have kind of some functions that map2 might be useful for, and I want you to discuss each of these with your neighbor. So the first task is for each of these functions, talk about which 2 arguments you might think about or you might want to iterate over at the same time, and then the second question is, for which of them might you prefer not map2, but one of its typed variants, so like map2 underscore int or walk2, for example. And I'll give you 3 minutes to talk to your neighbor about that. Okay, your 3 minutes is up. Are you ready? Okay. Don't make me tap the microphone, it'll be horrible. Ready? Let's go. Okay, so I'm going to kind of just run through the answers that I came up with. Those came up too early, but anyway. So download.file has a couple of arguments, one being URL and one being dist file. So it essentially visits a URL and downloads something to a location, dist file. So you might imagine you kind of have a vector of URLs you want to download and a vector of places you want to save them. It turns out, and I probably should have known this, that download.file is vectorized, so you could just give it a vector of URLs and destinations. You don't have to use map. But similarly, like you could, so what I really think about there is things like the dir.create function isn't vectorized. So map2 is probably not appropriate there, but the other one I was thinking about is file.move. Not file.move? Move.file, what is it? File.rename? Yeah, rename, that's it. That's what I was thinking about. I wanted to see if that one was... That one is also vectorized, so maybe not. But occasionally you'll come across kind of one of those functions that isn't vectorized and you really wished it was. And map2 is kind of a good solution for that. So our norm generates a sample from a normal distribution. You might imagine you're kind of doing a simulation where you're varying both the sample size and maybe one of the other parameters, the mean or maybe the standard deviation. So that would be a great kind of candidate for map2 to create sort of a list of all these simulated samples that you may then do something with. If you're more interested in sort of generating multiple samples that all have the exact same parameters, there's another function called rerun in purrr that's sort of designed for that, just doing something many times where nothing's really changing. So LM, as you probably know, fits a linear model. The kind of two most common arguments you might be playing with there are the data. What data are you using to fit the model? And the formula. What model are you fitting? So you could imagine you sort of have a list of data sets and a list of different models you want to fit to each one. So you could use map2 to sort of return a list where each sort of data set has been, or each model has been fit to each corresponding data set, and then you have all those results which you might do something else with. And similarly, like predict.lm, now if you have a list of models, you might want to generate predictions from those models. And it could be that you want to use different data for each prediction. So if you kind of have a collection of models and you want to do cross-validation, you've now got a collection of models that you need to fit to a sort of a collection of data sets. It's another good candidate for map2. And then the last one, write_CSV, it might be that you have sort of a list of data frames and you want to save each one out to a different file path. That's another great candidate for map2. And similarly, and we'll see this shortly, I think, ggsave, takes a plot and a file name. So you can imagine you have a list of plots and a list of file names, and you want to save each plot out to the corresponding file name. It's another really common use. And then the second question there was like, which one might you use, a typed or the walk-to variant? If you're doing anything with files, walk's often a candidate. So the two here would have been download.file and write_CSV. But you could consider, you want to kind of have a look at those functions and see what they return, because sometimes they'll return something that kind of says, did that operation succeed? So yeah, you might think about using walk2 here. It might be a little safer to use map2int because download.file does return an integer that's sort of a code on whether it was a successful or not. That might be something you want to check before you kind of move on and assume that they all downloaded. Okay, so to get some practice with map2, we're going to kind of take this code and think about using purrr to do the same thing. And the first thing I want you to do is just talk with your neighbor, take a look at this code and see if you can figure out what's happening. and I'll give you 2 minutes. Okay. Does anyone want to have a go at kind of describing in a few sentences what this code is attempting to do? No? Yeah.
So obviously we've got a directory where we've got different files with each different months of the year.
Mm-hmm.
For each one of them, we read it in and add a new column with of that month, and then at the end we put them all together into one version.
Yeah, so that was a great summary. So we, just to kind of repeat it for the mic, there's some directory, it's got files in it corresponding to different months of the year. They're being read in. Each data frame is getting another column that sort of matches the month that was read in, and then we're sticking them all together in one big data set. And this is an example that it's fictional, but it represents so many examples that I've seen in people's code, and particularly my students' code, where they're doing some kind of project and data lives in multiple files that have a very similar structure, and they figure out how to do it for one file, and then they copy and paste that code to do it for all the other files, and then they stick them together. And this is like a really simple example. Like normally I see this is repeated like 24 times or something like that, and I'm like, there's a better way, let me show you. So let's kind of work through this kind of so I think it's a pretty common task, kind of reading in multiple files, but really at the end of the day, what you want is one data frame that represents all that data. So let's take a look at kind of trying to reduce the duplication, and hopefully by reducing the duplication, we're going to reduce the chance of mistakes. Like it's very easy here, if you're using that copy and paste strategy, to forget to change one of these occurrences of a month's name, right? There's essentially, if I copy and paste, I have to change this Feb, this Feb, this Feb, this Feb, and this Feb, and chances are I'll miss one and screw something up. So we can already do kind of a lot of that task with what we know about purrr so far. So I'm going to create a months vector. It just has the names of those months. And I'm going to create those file names just by tacking on a .csv with paste 0. And then I can read all those files in just using map. So for each file and files, so files is now just these character strings jan.csv, feb.csv, and march.csv. So for each one of those file names, apply read.csv, read_CSV. And then sales underscore list is going to be this list of those 3 data frames. So it's going to be a list with 3 elements. Each element is a data frame. The one thing that doesn't achieve is kind of adding on that extra column for the month. So we're going to use map2 to do that. We're going to use the exact same strategy. We're going to solve it for one element, then we're going to write it as a recipe, and then we're going to apply it to everything using map2. But we're going to do that after the break. So you now have a break until 11:30. The kind of, what's the word? The incentive for coming back is that I'm giving out the purrr stickers at the end of the next bit after the break. So I'll be around during the break if you want to ask questions.